is another way for us to find the number of possible combinations. So the number of possible combinations. And for permutations, the order matters. And you'll see what I'm talking about in a minute. But the order matters. They're picky about the order that something happens. And generally, in probability, that's going to be written with a little n, capital P, little r. And what that tells us is that we have the total number and we are going to pick however many. So, there are two ways we can do this. One is by using a formula where it says the total number with the exclamation point. We'll look at that in a second. Tn minus r with the exclamation point. The exclamation point is a factorial key. So in math we use that exclamation point to represent something that is going down by multiplication. So if we add the number 5 factorial, what we're saying then is that is the same as 5 times 4 times 3 times 2 times 1. So instead of writing out 5 times 4 times 3 times 2 times 1, and especially when we get to really big numbers, they just use the factorial key. And you have a factorial key on your calculator under math, but we are not going to get it right this second. Okay, we'll look at it in just a minute. Today, on your assignment, you are even going to have some problems that are like this. 100 factorial over, let's go 100 minus 2 factorial. So if we had 100 factorial over 100 minus 2 factorial, that's the same thing as saying 100 factorial over 98 factorial. Your calculators are only built to do so many numbers at a time. So if you put in 100 and then hit the factorial key and enter, it will give you an error. It's like an overload error. It can't calculate that many things. But our brains are so much better, even though sometimes you doubt that, than our calculators, that if I was thinking this in my head, I could say, well, that's 100 times 99 times 98 times 97 times 96, times 1. And the one on the bottom is a 98 times 97 times 96 times times 1. What do you see about the top and the bottom?
Everything is the same except for 199.
Everything is the same except for the first two numbers. So what we can actually do, because our brain is so smart, is cross them off. So we could cancel, cancel, cancel. And really we can cancel everything from 98 down.
That's your favorite.
I know, it is my favorite. So then we only have 100 times 99 over 1. We don't even have to worry about the 1. So 100 times 99 easily goes into my calculator to give me 9,900. So if you get that overload message on your calculator, just remember, my brain is smarter and I can cancel everything down from wherever the difference was there.
You said the N stood for the number. What does the R stand for?
We're going to get there.
Oh, okay, good.
Okay. Alright, so I'm going to show you where that factorial key is on your calculator, but at the same time I'm just going to show you how to calculate the whole problem with your calculator today. So an example of when we would use this problem is if we have 4 members that are running for 3 different, let's go NHS offices. Let's say that they're going to be what? President, secretary, and vice president. In this case, the order matters because we're only going to pick some of them. There's only 3 jobs, so somebody's out of there. And it makes a difference if you're president or secretary, right? Just like if I said, okay, I'm going to pick one of you at random, and that person can go home right now, and I'll give you an A for the rest of the semester. And I'm going to pick a second person at random, and that person can wash my shoes. Does the order matter that you just got picked in?
Mm-hmm.
I would say so, because my shoes are in nice shape, but, you know, hey. So the order matters in this case. There are going to be some problems where the order doesn't matter. I'm going to pick 3 people, and you're all going to get free homework today. Then the order wouldn't matter. But when the order matters, we're going to use a permutation. And we could set up our permutation, and it's NPR. So, how this works is we're going to say, we have 4 possible candidates, the total number of possible candidates, and we are only going to pick 3 of them. So this is number possible, I guess. And this is how many we're picking. So if we have 4 possible, we're going to pick 3. And could you do this by hand? Absolutely. We could like keep throwing the names in there and do it, but it's going to take a lot of paper up. Where we could either use our formula from up here, NVR, or we're going to go ahead and just look at it on our calculator. So if you would get your calculator out. And we, on our calculators, because we have really nice calculators. We are going to, on our calculators, find the math key. Does everybody see it? And we enter it in this exact order. So we're going to say, okay, before we push our math key, I have 4 total kids. And I want to do a permutation because the order matters. So I go to math. So find your math key. It's right under my green key here. Math key. And we're doing probability. So you're going to arrow over here to probability. And then looking down here, look at number 2. See that NPR? Look at it matches with mine exactly. And then next one's what we're going to do when we do combinations tomorrow. So we're using both of them. But NPR, so I said I had 4 kids. And I want to do a permutation, so I'm going to pick that, number 2. And so I'm going to have 4 NPR, or permutation. And I'm going to pick how many again? How many offices did I have? 3. So I'm just going to say 3. And I'm going to hit enter. And it's going to tell me, if you can read my little fuzzy camera there, that there are 24 possible combinations that we could come up with. And that's it. That's how we do it. The whole spiel. And we can use that for a variety of different problems. If we wanted to do our, let's see. Oh, nope, we don't want to do that one. Yes, we do. How about your lockers? When you have your locker dial out there, that kind of lock that you have is called a combination lock, right? But it really should be called a permutation lock because can you put them in the wrong order? Like if your order is 33, 42, 15, you can't go 15, 33, 42. It won't work, right? But if we had our combination locks, how many numbers does that go up to? Does anybody know? 60?
60.
So we have 60 numbers available. And we're going to pick how many numbers for your locks are there?
3.
3. So how many different combinations could we make for a combination lock? You put in your 60 first, remember, and then your math. Over to probability.
205,320.
205,320 possible combinations. Which is why it makes your lock pretty safe because what thief is sitting there running through 205,000 different combinations, or even remembering which 205 they tried.
Safe until you give it out.
Well, right. That's an issue. Alright, so we're gonna try a few Venn diagram problems, we're gonna try a couple of permutation problems, and then we are going to wait till tomorrow for our combinations and expected values. So, we are all set with notes, Ms. Boyer.
I was just giving the board a quick view there, so.
So